itu ya kepada kita terkait dengan evaluasi interaksi tanaman tanah gitu ya di sistem agroforestry. Nah, sebelum kita mulai, semuanya sudah scan barcode di depan untuk mengisi presensi. Sudah? Yang belum silahkan mengakses dulu barcode-nya untuk mengisi presensi. Kursinya. Saya beri waktu 1 menit. Jangan sampai tidak mengisi ya, karena ini adalah pengganti presensi untuk minggu ke-7 di mata kuliah Agroforestry. Sudah? Oke, kalau sudah selesai, sekarang silahkan dimatikan HP-nya, kemudian disimpan ke dalam saku atau ke dalam tas masing-masing, sehingga kalian bisa fokus ke depan untuk mendengarkan materi yang akan disampaikan ya. Tapi sebelum kita mulai, kita akan mendengarkan dulu sedikit pendahuluan ya terkait dengan untuk apa sih apa kuliah tamu hari ini dilakukan. Akan disampaikan oleh Profesor Kurniatun Buco ya. Untuk Buco, saya persilahkan ke depan untuk memberikan ya sedikit pembukaan terkait dengan kuliah tamu pagi hari ini. Monggo Bu, silahkan.
Baik. Assalamualaikum warahmatullahi wabarakatuh. Ternyata kalian tuh sudah semester 6 ya. Kok masih imut-imut? Tak pikir masih semester 2 tadi. Semester 6. Anak-anakku semuanya, kita bahagia sekali ketemu pagi ini. Saya mau mengucapkan masih lebaran kok ya. Selamat Idul Fitri. Mohon maaf lahir batin ya. Kosong-kosong kita. Ya, ya, oke. Apa sih agroforestry ini? Why we have to talk about agroforestry? Nah, ini saya diminta oleh Bu Rika untuk memberikan pengantar mengapa kita harus care about agroforestry. Dulu kita di pertanian nggak perlulah mikirin pohon-pohon segala. Dulu tanam satu macam tanaman sayuran, kemudian pangan, udah gitu aja. Kedelai, habis dari padi, kedelai, jagung, beres. Sekarang nggak bisa. Karena perubahan zaman, semuanya telah berubah. Iklimnya telah berubah. Pasarnya telah berubah. Demand-nya berubah. Polusinya pun terus berubah. Nah, pengetahuan ini tadi perlu kalian dapatkan pada saat kalian belajar di akhir dari semester berapa ini? Akhir dari semester 6. Agroforestry. Ya, next Mas Santo. Ya, so agroforestry di awal kuliah ini saya sudah memberikan ada AF0, AF1, AF2, AF3. AF0 itu agroforestry, agriculture and forestry are completely separated. Ya, seperti orang tua kita yang masih belum kenal satu sama lain. Oke, atau mungkin saya tidak kenal satu sama lain. Yang kedua, itu at the plot level, agroforestry itu ada perpotongan antara agriculture and forestry, ada interaksi, ada perpotongan di tengahnya at the plot level, di mana kita akan berbicara saat ini, pagi ini, di plot level, di mana pohon-pohonan ditanam di lahan pertanian, lahan milik petani. Nah, itu tidak semuanya sukses. Semuanya itu ada yang sukses, ada yang enggak. Nah, yang enggak ini tadi pasti kalian, oh ini petani bilang enggak cocok. Ini berkompetisi. Ada yang saling mendukung. Nah, ini semua banyak macamnya agroforestry ini. Bagaimana? Apakah kita untuk membantu memanagenya, untuk menekan kompetisi ini tadi? Apakah harus melakukan pengukuran, percobaan lagi dan seterusnya? Kalau untuk jangka panjang, pohon umurnya berapa, Mbak? Mau pohon umur berapa? 20 tahun, muda. 20 tahun. Bayangkan nunggu 20 tahun kapan kalian lulusnya? Iya. Nah, itu dia. Makanya ada modeling. Jadi menggunakan tools dengan berdasarkan matematik ataupun pengetahuan yang lainnya dari statistik ya. Nah, dari sinilah ada AM1. Tapi nyatanya di landscape agroforestry itu banyak macamnya. Lahan tidak hanya agroforestry saja, kita punya hutan, tuh, ataupun sudah terdegradasi. Ada juga yang pertanian monokultur, ya. Ada lagi perumahan. Nah, dari semua itu ada di perpotongannya dari aneka macam penggunaan lahan in the landscape itu ada di AR2. Nah, tadi sudah saya sampaikan global issue itu perubahan iklim. Ini nanti juga nyangkut juga walaupun di luar level isunya ke landscape dan juga ke perubahan iklim. Bagaimana kita menciptakan agroforestry yang resiliensinya tinggi, bisa beradaptasi terhadap perubahan iklim. Next slide please. Ya, nah disinilah ada buku yang kebetulan penulisnya juga ada di sini. Nanti biar diceritakan oleh beliau sendiri tentang Sustainable Development through Trees on Farm. Jadi peta ini agroforestry ini sudah memasuki 5 dekade dan ini tidak ada 3 level dari agroforestry. Next slide please. Nah ini mungkin teman-teman atau juga kalian semua anak-anakku ini sudah pernah saya tunjukkan dari hasil dari India bagaimana anak kecil bisa mempunyai kreativitas dan imajinasi. What is agroforestry? As you can see here, agroforestry always have a people. Forest, natural forest, no people. But agroforestry always have a people. The second is should be having a trees. Well, not only trees, but it's also you could see diversity, maintaining biodiversity, water, education, and soil. Don't forget with the soil, yeah, because in climate change era, soil plays very important role to support the sustainable production and a good health of the people, environment, and so on. Okay, next slide, please. What we have done so far. At Brawijaya, we have already agroforestry started in 1984. Sudah lahir. Mimpi pun belum. Ya, 1984 we started, and you could see here that on the left that is AF1, that is how Wanulkas been developed by Professor von Oorbeek, and we supported in the field with our research collaboration with the Netherlands related with the alley cropping. And you could see here the roots distribution being observed and being control it to have a competition between trees and crops. The second level, this one we are talking about the function of trees related to the slope stability at the landscape level. The second level, yeah, landscape level related with the erosion, related reducing the landslide, and then the other one is related, of course, not only with the water, but it's also with the soil health. So, and the second one and the third one, we are talking about the, well, many disasters. It's not only with the climate change. We just recently have the eruption. Kita tinggal di pegunungan, nggak bisa pisah dari erupsi, dari macam-macam gangguan. And you could see here bagaimana Brawijaya mengangkat research agroforestry yang belum banyak tersentuh pada waktu itu kita kembalikan kepada petani. Ya, kita menggali permasalahan, pertanyaan dari petani, kita research, kita evaluasi, kembalikan kepada petani. Dan dari sinilah bagaimana regeneratif atau agroforestry tadi untuk restoration. Next slide please, the last one. Ya, penelitian yang terakhir ini kita tidak hanya sampai pada just a matter of interaction with tree and crops, but it's also how to interact with not only with soil but with farmers and market. Disinilah Ibu Rika dan kawan-kawan dan juga dari mahasiswa itu banyak terlibat dengan Vanili in Agroforestry Systems. Ini bagus sekali harganya, tapi dari segi lingkungan, bagaimana pengaruhnya? Adakah pengaruhnya dengan itu? Nanti kita tunggu dari hasil penelitian kakak-kakakmu. Dan isu sosial juga masuk di sini dan juga ekonomi ya Bu Rika. Nah, itu nanti kita tunggu hasil berikutnya. I wish you all enjoying the discussion for today, tree soil crop interaction. Agroforestry yang pertama adalah bagaimana meminimalkan kompetisi dan memaksimalkan komplementer. Sama dengan kita berada di sini semua. Kompetisi bagus, tapi bagaimana ini menekan kompetisi yang komplementerinya saling melengkapi harus kita pertahankan. Saya kira itu saja dari saya. Enjoy your day. Have a good day. Thank you so much. Sukses selanjutnya. Wassalamualaikum warahmatullahi wabarakatuh.
Baik, terima kasih banyak Bu Jo atas pengantarnya. Teman-teman sekalian ya, sekarang kita akan memasuki sesi kuliah tamu dari Profesor Meina. Mas Anto bisa minta tolong untuk ditunjukkan CV-nya. Jadi Profesor Meina is a professor agroforestry from Wageningen University and Research. Pak Meina juga merupakan Distinguished Science Fellow at C4 and ICRAF. Ya. Kalau kalian bertanya-tanya publikasinya bagaimana, nah nanti silahkan dibuka Google-nya, kemudian di search, dimasukkan nama beliau ya, dilihat sendiri. Banyak sekali riset tentang agroforestry, ya, mulai dari yang paling kecil gitu ya, roots spesifik sampai ke skala global environmental policy, semuanya ada di situ ya. Tanpa berpanjang-panjang lagi karena kita memiliki waktu yang sangat terbatas, so I would like to invite Prof. Meina to come forward. And now, yeah, the floor is yours, Pak. If applause, please.
Terima kasih, selamat pagi semua. Yang pertama, kami harus decide on which language will be used today. Bahasa Jawa, button. Bahasa Belanda, bahasa Prancis, bahasa gambar, bahasa matematika. Ini bahasa modelan, apa itu modelan, ya. So I will speak English, but if you ask questions, interrupt please. Bahasa Jawa saya belum mengerti, maaf ya. Tapi otherwise, okay. Yeah. So it's a pleasure to talk today. Introduction to the model, and Monica asked me this title. And I think there are already many words in the title that we first need to know what do we mean by that. What do we mean by agroforestry? Ucho already talked about EF0, EF1, EF2, sudah mendengar? Yeah. Tree soil crop interaction modeling. So the first question is agroforestry systems. How many agroforestry systems are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 100, 1,000, 1 million. How do we know? How do we know how many agroforestry systems there are? Well, let's start with trees. How many trees are there in the world? How many species of trees? 1, 10. How many trees do you know? Pohon jati. Ada lain? Pohon pinus. Duren. Lagi? Cengkeh. 4. Lagi? Hanya 4 pohon? Atau ada lebih? Lebih ya? Di dunia total ada 50.000 spesies pohon. Apakah semua cocok untuk agroforestry? Mungkin. Tidak tahu, tapi banyak, pohon banyak. Kalau crop, tanaman pangan, ada padi. Ada lain? Ada jagung. Ada kedelai. Lebih? Kopi? Vanili? Banyak ya. So, setiap spesies pohon bisa dicoba dekat dengan spesies tanaman pangan. Tapi tanah berbeda juga. Ada berapa? How many types of soil are there? 1, 2 types of soil. Ada pasir, ada resaba, apa? Clay, silt. So 3 types of soil. Sand, clay, and silt. Tapi ada andiso dan volcanic berbeda juga. Ada tanah asam, ada bercampur. So banyak macam tanah. Yeah. So agroforestry dengan with the tree, a soil, and a crop. We have so many trees, and we can combine with so many crops on so many types of soil. What can we do? Yeah. So how can we know something about agroforestry if there are so many different types? If it's only one type, well, or with rice, we have one crop, and Isava, the 2 types of environment, and we can try many types of fertilizer and many types of spacing, but we can still do experiments and find out which is the best way to grow your rice. But with agroforestry, if we have, Pucho already said, if we have to wait 20 years before the trees are done, and we have so many types of trees that we would like to try, in combination with so many crops, on so many types of soil, in so many climates, too many, yeah? So what can we do? How can we try to find out something about so how can we learn something about agroforestry systems? Experiments is not so easy. So what can we do?
The trial modeling.
Maybe we could learn from another literature like journal or articles.
Try to read an article, yes. What else can we do? If we want to find out about agroforestry, if you stay in the classroom, you will never, you can read a book and you can open your computer. If we go to the field, what can we do?
Maybe we should try some experiments, but also in the same time we have to learn from the other person. I mean, look for our surroundings.
So we can go to the field and observe. What do we see? Yeah, what types of agroforestry? If we go to Nantang, how many agroforestry types can you see? Well, we see already a lot of different things. What else can we do when we go to the field? Can we just walk there and observe? What else could we do? If we want to find out something about agroforestry, what would you want to do?
Maybe some like other friends can experiments and
You go to the field and then you open your laptop and you study literature. What else could you do when you go to the field? The same. What else when you go to the field? What can we do?
Maybe we could take some sample, I mean soil sample, to do a simple research in the laboratory, in the lab scale, and then we could also do a wawancara, yeah, interview.
Yeah, I was looking for somebody who wants to talk to the farmer. That seems to be so difficult, but yeah, we can talk to the farmer. Harus bicara bahasa Jawa ya. Saya belum bisa, tapi kalau bahasa Indonesia saya mengerti. Tapi yeah, yeah. So we could. How can we learn something about agroforestry? Well, we can explore and observe what is it that we see. We can talk with the farmers. And of course, the men and the women may have different stories to tell. They may have different ideas about what type of trees they like and why. We could do experiments, but then, yeah, too many options, too many ideas. We first need to narrow down what type of experiment would be useful. And then, model. And model, some people call it experiments in silica. Silica is a type of soil. Anyone understand the silica? In your computer consists of chips, and the chips contain silica. So when people say we want to do experiments in vivo, in life, in vitro, in the laboratory, or in silica. So you do experiments on your computer in silica. Yeah. So my task today is to discuss what can we learn from agroforestry in models with experimentation in silica. Yeah. Well, that brings us to the question: what type of models? What does the word model mean? What type of models do we have? What do we know about models? When you hear the word model, what do you think of? What? Predict the future, yes. What is modeling? But let me see. How do we talk roughly about this? I'll come back to that. Here we have ini modeling. Ini modeling. Siapa ini? Einstein. Siapa? What is the model? E is mc square. Ini model di kimia, in chemistry. Here, model. A model with trains and the landscape and the real world. Here, model. Statistic. Here. So, there's so many types of model. Which one should we use? I have a nice model here of agroforestry. Is this a model of agroforestry? What do we see on the picture? Farmer. Where is the connection with agroforestry? Cannot see from the back. Can I come closer? Is this a model of agroforestry? All the products that they carry, all the food, all the fruits. Where does it come from? Agroforestry. So, this is the model of agroforestry. The product that people get from it, whether they are happy or not. And it looks beautiful, isn't it? So we call it Gambar Indah Sekali. GIS. Gambar Indah Sekali. But what can we do with it? Well, we can watch it. Can we do experiments with this? But you cannot do much with it, yeah? But it's only 2 dimensions. Ini, model berbeda. Model 3 dimensi. Ini model agroforestry. Kenapa itu model agroforestry? Ini burung yang makan buah. Bird eats the fruits. The bird disperses the fruits. So the trees that you grow, maybe they grow there because the bird planted the trees for you. So a bird is part of the model of agroforestry. If we want to understand which trees grow there, we may start with the birds. Which birds were there to plant the trees for us? So is this a model of agroforestry? Yes. The previous one was 2 dimensions. This has 3 dimensions. But what is missing? It is moving. We can move it around. But it is not growing. It is not the bird in the air. Just like this. Yeah. So we want models that not only look nice, that not only have many colors and many dimensions, but that are dynamic, that help us understand something about the system that we study. Yeah, so back to this thing about the model. What can we do with the model? Well, we can watch it. Maybe we can learn something from a model. Maybe we can imagine that we are the person, that we are the model, that we are Mr. Einstein. Maybe we can use a model to do experiments, like we said, the experiments in silica. We use the model So the using the model is about making experiments in the model, or we can make a model. Did you ever make a model? Have you ever made a drawing? Have you ever made a model like this? Have you ever made a drawing of something? And the important thing is that you think about the real world, and you think about what do you find important, and your drawing is about those things that you find important. And the drawing generally has a topic, a focus, and has a context. So the drawing is about something that you find important, and you think about the context. Well, those are important steps in modeling. Yeah, so when we want to make a model about agroforestry, we first need to think about what is important about agroforestry. What is it that we want to find out? Yeah, so with that here, we have 4 ways of learning something about agroforestry. First one, the survey what exists. And the problem with something that exists is that you need to know the history and you need to know why. Why is it there? You may easily find that the soil under the forest is the poorest soil, and the soil in the Sava is the best soil. Is that because the rice makes the soil fertile and the forest makes the soil poor? Or is it that all the good land was used to make Sava and all the poor soils is left with the forest? Yeah. So observation, when you want to take a sample of the soil, good. But then you know what is there. You don't know, is the soil poor because of the forest makes it poor? Or is it the forest is there because it was a poor soil? Yeah. So with observation we cannot separate the cause and the effect. Second was talking to the farmer. Took a while to get there, but we can talk about many things. We can talk about the what, the where, why, how, so what, who cares. So many topics we can discuss with the farmer. We can also discuss with the farmer the strengths, the weakness, the opportunity, the threats. We can also, and that's very important with the farmer, we can, from the current, look back at the past, what happened before and how did we get where we are, and we can look into the future. Okay? So a discussion with the farmer can really explore that concept of time, and we observe what is here now, but we want to know what happened before and how did we get to where we are. And once we know that, we might think about where are we going, what would the future bring. Yeah, so after talking to the farmer we may have some idea about the future. Certain things are desirable and we would want to grow we want the trees to grow faster, we want the crops to be more productive, we want the soil to be sustainable, we want the environment to be good, we want the economics to be, we want everything. Is that possible? Well, maybe a bit. But there are many constraints. It's not that suddenly if the trees grow much bigger, maybe the crops become smaller. If we put a lot of fertilizer, the crops may grow fast, but we may pollute the environment. So experiments deal with trade-offs. And yeah, as we said, there are way too many things you may want to include in your experiment, so you better think carefully what to do and what to expect. And that's where the models come in as a way Now, within models, you have two approaches. One approach is if you have your class on statistics. All statistics is about interpolation. I have a lot of observation points and I want to see what is the relation between. Well, as long as you are in the conditions where these data are collected, the interpolation is a very effective way. But if the conditions change, you're not sure that the regression line will hold. Are the conditions changing? Is the climate changing? Is the environment changing? Is the weather changing? Are the prices changing? So, if we interpolate between the data from the past, is that safe for the future? No, we want to know how does it link with the changing climate, with variable prices, with many things. Yeah. So that's why we get to the process-based modeling, the extrapolation. We want whatever we have learned from the past to feed the model, but then to use it under new circumstances, to see what would we predict to happen if this, if that, if this, if that, and then see which ones are. Is that safe? Can we trust the model? No, please don't trust any model. Is it useful to make a model? Maybe. Even if we can't trust it, it may be useful, at least to try. Yeah? So this is the simplest model. It's called garbage in, garbage out. Do you understand? So if the input to the model is garbage, what can we expect from the model output? Be garbage. Yeah? So we've been making models, we've been training people to use the model, but we always ask them first, and please join me singing a song. Don't believe the models you will see, unless the data agree. Don't believe your data again, unless your models explain. However, suspicion will be on you if agreement is too good to be true. Penalty? So don't believe the model. Don't believe your data, because actually your data are also a model. And the data come from reading some instrument. And your measuring device is a model. And don't trust the model unless it matches with other things that you know. So don't trust anybody, but do trust yourself. Do trust that you can learn. Nothing will be perfect, but if you try, you can gradually make it better, gradually make something more trustable. Yeah, that's the philosophy. So, what do we do with the model? We can, if you read the newspaper, you'll all the time see the economists predict that inflation this year will be 4%, 5%, 6%. Economic growth, the target is 6%, and now we only achieve 5.1%. And now, because of the war in Iran, it is now 4.7%. So you'll see results of models all the time. And what do you do? Oh. Oh. Do you believe it? Don't believe, don't believe. You can also use an existing model with applied to a new circumstance. Yeah, so okay, the rainfall last year, the rainfall was 1500 millimeters, and now I want to try what would have happened if the rainfall would have been 1600 millimeters. Is it different or not? So you can use a model, you tweak one parameter, and you see what the outcome will be. Can you trust that? Don't believe, but yeah. Also, you can use a model and not only change the parameter for the rainfall, but also now I want to go to Malang Selatan and try out on a limestone soil, and the soil is shallow or the soil is deep. Would that have impact on the agroforestry? So 3 is sort of using a model, but now taking it to some circumstances that are quite different, but still it's possible to go there and observe until see whether the predictions of the model match with what happens if you talk to the farmer. So level 3 is you should be able to change the parameter, you should be able to run the model, you should be able to interpret the results. But with that, you keep the model as it is. I think for you in your agroforestry course, it would be nice to achieve to get to this level, right? That you're able to use a model like the one we're going to show here, and use it in modifying not only one parameter at a time, but bring it to a new circumstance and see what would happen there. There are more levels, that is, well, this is the model, but actually I know more about this and that, and I want to change it. So you can add things to the model. So the process is not yet there, so you can, well, that is, if you're a PhD student, you can use that with your model. Try to add new things to it. Or you can even start from scratch and make a new model altogether. Yeah. So the user friendliness of a model depends first of all on the transparency. We talked about inflation of 4%, whatever. You ask, well, how did you get there? What is the basis of it? Is it garbage in, garbage out? Is anything better? To use the model, it's a question of get it on your computer, download the software, and find the button to press, and it will run. And if it runs, okay, you look at graphs and tables, and you look at the output and try to understand what's going on. I hope some practicals you will be able to use some of that with the model that we have. If you want the model to really go to new circumstances, then the question of the model is how versatile is it? How flexible is it? Could it be used to something quite different? Yeah. And if you want to modify the model, the question is how open is the code, the software behind it, and can you actually go in and change things on that level? Yeah, so there have been various models for agroforestry over time. I'll be talking here mostly about that middle one, the Vanulkas. The water, nutrient, light. So water and nutrient is in the soil, light is above ground. What do trees and crops do with it? They capture it. They capture the water, they capture the nutrients, they capture the light. So if the tree and the crop are both capturing the water, the nutrients, and the light, are they competing? Yes. Can they be complementary? Can the tree use some resource and the crop use the other to some extent. The model is about competition and complementarity, like Pucho said in agroforestry. So Manulkas is water, nutrient, light capture in agroforestry systems. So the model looks a bit like this, yeah. Only now there's a they have roots in the soil. The soil has different layers and different colors, different properties of soil. And there are different zones. There's a zone close to the tree and there's the zone a bit further from the tree. And the crops can grow here and there. So the model, agroforestry model, looks like this. If you make a drawing of agroforestry, you might start with something like this. A drawing like this would help you understand what is there at the moment. In the model we want to see, but it is, now we plant a crop and the first week it will be very tiny and then it will get bigger and bigger and bigger. It will change over time and the tree will drop its leaves. What happens when the tree drops the leaves? Yeah, they fall as litter on the ground. What happens with the litter on the ground? It decomposes and the nutrients become available, or the nutrients leach down to the... So if the nutrients become available at the time that the crop needs them, it will be fine. If it comes too early or too late, it will not. So the timing of the decomposition is an important part of the process. Yeah? I developed this model with a number of colleagues. Some are here. But so this is, if you, at the moment the model is implemented in the Stella environment. We've been transferring the model to another language, to the language R. That is still, we're testing at the moment whether it gives the same results or not, but hopefully later this year it will be available. And the model consists of many different things. So there's the the growth of the crop, the growth of the tree, what happens with the water, what happens with nitrogen, what happens with phosphorus, what happens with erosion, sediment. So many things are happening. Too much to talk about now, but you're welcome to explore. Now, the basic language of a model like this is called stock flow. So you ask yourself, what are the stocks? What is current? What is observable? What is there in the system at any point in time? And those are the stocks, the things you describe. And then the flow is what happens with them. What is the change from one time step to the next time? Yeah. Now, if I say there's one stock of water, there's water in the soil. What that added to it when it rains, so when it rains, there's inflow, the soil gets wetter. And there's one outflow, the crop is using the water. There's another outflow, the tree is using the water. And we can see the competition between the crop and the tree. If there's a limited amount of rain, how much will the crop get? How much will the tree get? So the minimum structure to look at competition is something like this. But it is, if we add the third outflow, we say that drainage is also possible. Water can leave the soil to groundwater or to surface water. Then what was a win-lose thing becomes possible complementary. So we now start to see that if there's an environmental outflow and uptake by the crop and the tree, it's possible that with the crop alone there would be more water draining down because it comes at the wrong time. And with the tree there, the total water used by the crop plus the tree can be higher than it was by the crop alone. So there is complementarity. It's possible that agroforestry is using the resources more effectively than a single crop. And that's quite a basic idea in agriculture. And I want to get, sorry, if you go to a national park in Africa, here is Nairobi National Park, you go there, and then when you enter, you see a big sign, and the sign says, all animals are dangerous. All animals are dangerous. And people get disappointed. I thought there would be many different types of animals here. And now I see that they're all dangerous. There are kangaroos and they're dangerous. And all these animals here are dangerous. So a basic assumption of making a model is that all trees are the same, except for all crops are the same, except for all soils are the same, except for. So a small experiment. These two rows will try to tell me after 5 minutes what are the difference between trees. How should we describe trees in a way that one tree is different from another? You take 5 minutes and tell me about the crops. How can we describe difference between the rice, the jagung, the kadele, the whatever? So if the model crops in the model, how many crops do we need and how do we describe the difference between? You will tell me about the soil. How do we describe the difference between the soil? You will talk about the management of space. How can we describe where is the tree, where is the crop, how is the space used, what should we include in the model? You here will tell me about time. What do we need for time? How do we need to describe that things happen during the model? And you will tell me about the management by the farmer in terms of what can the farmer do? Put fertilizer, prune the trees, whatever they can do to manage the agroforestry system. Yeah? So the model was simple because all trees are the same, all crops are the same, all soil is the same, all spacing is the same, all time is the same, all management practices are the same. But we disagree. How should we describe that trees are different?
Canopy structure, nutrient.
So we describe the tree, there's a stem growing, there's a canopy, there's an architecture, and some trees may be broad and others may be tall, some may be narrow. Some are tolerant to drought, some are less tolerant to drought. Some are able to fix nitrogen. Some have mycorrhiza and some have not. Some may have shallow roots, some may have deep roots. So there are many things that we need to know about the tree before we can run the model. What are the crops? Are all crops the same? No.
Crop isn't the same. It's totally different between like example like ornamental crops and food crop is totally different. Food crop is for how we use it as a food, but ornamental crops how we use it as flora in our home. Example like that.
So the crops are different in terms of their use, but do they all grow the same way? Some are, or is it a bit like the trees, that some crops are tall, like the jagung, like the maize, and other ones stay close to the ground? Some may have deep roots, some may have shallow roots, some may be fixed nitrogen, some are not fixing nitrogen. So there are many aspects. Some grow fast, some grow slow. If you grow ginger, it grows slowly. Some is shade tolerant, some is not shade tolerant. So there are many ways in which the crops are different. How about the soil? Are all soils the same? What do we need to describe that one soil is different from another?
Okay, soil in what we can different about the soil, we would see about the texture, if that is the particle size or something like structure, structure, and the pyroclastic soil.
Okay, so the soils differ in texture, they differ in structure, they differ in how deep the soil is. Is it shallow? They differ in density. Can the roots penetrate or not? They may differ in water holding capacity. They may differ in pH and aluminum toxicity. They may differ in phosphorus fixation. So the soil group will tell me that there are many different things to know about the soil. How about the space?
For the space is what makes it different is the placement of the trees and the crops, and it's determined by the type of roots and the types of canopy that the trees have and what the crops need for the light to strike them.
Yes, very good. So space, one thing is about where are the crops, where are the trees. It also could be something about slope. Is it the land flat or is it sloping? Yeah, so there are many ways to describe the spatial arrangement. What about the time? What aspects of time should the model include?
The time in agroforestry is different because it has short-term crops and long-term trees.
Yes, but the question is, when do you plant the crop? Do you all plant the crops at the same time, or do you plant something close to the tree first and then something further away later? Do you plant the same crop every year, or do you want to grow maize and the next year soybean and the next year cassava? So what is the timing of the crop? But also the tree. Do we start with the big tree, or do we start with the seedling of the tree, and the tree has to first grow, and there's intercropping in the early stages when the tree is still small, and later on when the tree is bigger, the intercropping is changing. And so time is we need to be quite flexible with time. Finally, the management. What type of management should we include?
Maybe the management itself depends on who operates it. Like a farmer, a female farmer and male farmer will operate the agroecosystem or agroforestry differently. Or maybe it depends on the components. Like some agroforestry system had like farm, like cows and goat or chicken that farmer use their bioproduct to be fertilizer.
Yes, very good. But let's see, before we can get to the male or the female farmer, what can they do? Well, they can apply fertilizer, they can apply manure, they can apply compost from outside the system. Inside the system, they can prune the trees, they can change the density of the. So there are many things. Flexible management should be possible in the model. Yeah. So we started with saying that all trees are the same and everything is the same. But when we talk to the tree experts here, they tell me, no, not all trees are the same. We need. So, okay, fine. Tell me for your tree, what are the properties that we need? So we end up with what we call a library of parameters that describe that the durian is like this, and chenke is like that, and jati is like that, and pine is like that. So to tell the model that we're not talking about any tree, but we talk about a tree with these properties. Similarly, we talk to the crop people, and they tell me, no, not all crops are the same. I say, okay, fine, tell me, what is your crop? How fast does it grow? Where are the roots? All the properties that you described, we go back to saying parameters. Tell me, what are the parameters? What is characteristic of your current crop? The soil people, fine, all soils are different, but tell me, what is the depth of the soil layer? What is the texture? What is the interaction with water, with phosphorus? The space people, okay, there are many different ways of arranging the trees and the crop. Tell me what you want to do. The time people, okay, we need a calendar. You need to tell me, when did the tree start? When do the crops start? When do we harvest this? All the management things need to be there. Management people, give me a list of when do you apply fertilizer? When are you applying organic inputs? When are you pruning the trees? When are you thinning the. So that's why the model becomes so difficult, so complex, because we need to satisfy all the tree people, we need to satisfy all the crop people, all the soils people, all the spatial, all the temporal, and all the management practices. Masdani, how many inputs do we need before we can run Manulkas? How many inputs, parameters do we need before we can run the model? Well, the tree library has 70 parameters, and the crop library has 25 parameters, and the soil has a lot different tables for different layers of soil. Management has to specify these zones and this and that. Temporal calendar is like this, and the management is like that. So, in the end, the model was supposed to be simple, but when we listen to all of you, all the experts, I get more and more complex. Now, that's what happens with the Vanulkas model, and that's where we are now. And so, I think I probably. So we have, in terms of space, we can talk about linear systems, we can talk about circular symmetry, we can talk about sloping land. So we have different ways of interpreting zones. And we can make models about hedgerow intercropping on sloping land, or timber trees, or oil palm with cassava or rubber. So the same model can be used, can be specified with different parameters to simulate very different agroforestry systems. But this is the list that we have of the parameters. Right? So before the model can run, we have to tell this is the soil, and that is the tree, and that is the climate, and that is the. Yeah, so that's why it becomes a bit complicated to run. So this is the model, and I hope that you have a chance to, at some point, look at it and make a run and interpret what happens. It will tell you that the tree is growing like this, the crop is growing like that. But then remember, don't believe, don't believe, don't believe the models you will see unless your data agree. Don't believe, don't believe, don't believe your data again unless your models explain. However, suspicion will be on you if agreement is too good to be true. Thank you. Questions? Vika or anyone? Questions? Danny, you will help? Okay.
Thank you for the insightful presentation, Pak Meno. Now we still have around 20 minutes for question and answer. If you have any question, just raise your hand. It can be in English or in Bahasa. Yeah, in Java is also okay. Yeah, any questions? Yes. Please mention your name and what is your questions about?
Okay, thank you for your presentation, sir. First of all, my name is Jasmine Amira, and I would like to ask you about questions. So our main issue in Indonesia is deforestation, right? So with deforestation still being a significant challenge in Indonesia, how applicable is this modeling approach in actually informing land rehabilitation efforts or sustainable agroforestry planning on the ground? That's my question.
Good, thank you. Well, what is a forest? How many trees do we need before we call something a forest? 4? No, more. So deforestation talks about either it's a forest or it is a non-forest. Is there nothing in between? Well, agroforestry in many shapes and forms is sort of in between a real forest, a nature forest, and agriculture. If we want to understand why do we care about deforestation, well, it may change the hydrology, it may change the water, it may change the climate, it will change the biodiversity. So we care about deforestation because it has impacts on many things that happen in our landscapes. But it is not black or white. Yeah, there are many things in between. And if we want to know what type of agroforestry is still similar to a natural forest in terms of water, in terms of carbon, in terms of nutrients, well, then a model like this can help, because the same model, we can make a forest. Forget about crops and just grow different trees and let them interact with the soil and the climate. And we could see what happens with the soil if it is only trees. So a model like this can help to deepen the question, help to modify the question. The question not black or white, it is forest or something degraded. No, there are many things in between. And if you would plant trees, can you have a gradual change over time in restoration together? Can farmers still grow their crops? First couple of years, yes, and then the shade will be too dense and this and that. So a model like this doesn't give you the answer, but it allows you to explore many scenarios. And then if you've seen that, okay, this type of restoration seemed to work in Kalikonto, and then somebody want to bring it to Malang Selatan, and the soil is different, could you expect that something, a positive story that you hear about restoration in one place, would you expect that it works somewhere else? Well, the model can allow you fairly quickly to say, now if I change the property of the soil, it may not have the same effect that we wanted or not. So again, a very good question. The model doesn't answer it. The model doesn't tell yes or no. It tells many in-betweens, and it will tell you many it depends on, and it will tell you it depends on what type of tree it was and what type of soil it was and whatever. But yeah, it can be a useful tool to tease apart all these things that are embedded in the question that you asked. Yeah, but as we said, any statement about agroforestry is good or agroforestry is bad. There were thousands of trees possible, so there are maybe 1 million type of agroforestry systems could exist in Indonesia if you look at that. Any statement about agroforestry is good. Well, some forms of agroforestry are good in certain places for certain purposes if you manage them well. But if you think that we now have this solution and now we make a national policy, the president declares that from now on all farms should be agroforestry, will that work? Of course not. Of course, it is a direction to search. It is not an answer. It's not a destination. It doesn't, yeah, if you say agroforestry, no. Where agroforestry helps is that before we had agroforestry, these people are agriculture, these people are forest, and there is a line between and no one is allowed to cross. And forest should be managed by foresters, and agriculture should be managed by agriculture, and there's nothing in between. Agroforestry helped to say now we are all in the same room, and our models should be able to address the difference of trees and soils and crops and this and that. So agroforestry helps if it says we should abolish this thick wall between agriculture and forestry, and we should together look at what happens. In that sense, agroforestry helps. But not to say, well, you should plant the jati trees at 3 by 4 and plant maize at 1 by 1 for the first year, and the second year you grow it. No. In some places that may work, in some places not. And we need to be very flexible. And it is your job as a professional to help people understand that between forest and non-forest, there's so many different options, so many different ways to, if it doesn't work, you can try this, if it doesn't work. If you hear somebody, oh, but I had very good results here, okay, fine. Happy that you have good results. It doesn't mean that we can do the same unless the data agree, unless the models explain.
Thank you, Pak. We still have maybe one more question.
Hello, my name is Wildan Prayoga, and my question is it possible to add a socioeconomic parameters in the model? Because as we know in Indonesia, our farmer have a smallholder area, so I think the economical value is still be a concern for implicate the agroforestry system.
Sure. Yeah, no, but a very important point. And so we often talk about bioeconomic models. Most of the time, a bioeconomic model means first the biology, how would it grow, and then the economics. So we first use a model like Vanukas to say, well, you can harvest maize here and timber here, and so these are the products that would come out of your system over time, and we can analyze, but we use so much input, the cost is this much and the benefit, so we can do an economic cost benefit calculation after we've run the model. So most bioeconomic models are bio first and then economic. However, it is also possible to have a more feedback between the economic and the bio. It would be easy to add a constraint and say, well, if you want to fertilize, that costs money, and if you don't have money, sorry, you can't fertilize. So we can either say upfront that using this fertilizer would not be feasible for farmer X, Y, or Z, and it might be possible for another. It would also be possible within the model to do the cost benefit. Actually, within Vanukas, we do an economic translation, and we keep track of what is the economic status of the farm. Another part of bioeconomic has been the question of what crops to grow. Yeah, in the simplest form, you say, well, the first year I grow maize, and the second year I grow soybean, and then I grow cassava, and that's it. We can, however, and we did that in models about teak growing, say, well, because you then see that if the trees go fast, after year 3, it isn't really worthwhile to grow anything, it's too shade, but the model told me to grow the crop. So if we get decisions, rules in that the farmers will grow the next crop, but only if the previous result was still reasonable, okay, then you start to see that if the trees grow slowly, farmers can crop many years and will get more income from the crop but less from the tree. And if the trees grow fast, will be less income from the crops but more from the tree over time. So we can bring in management decisions for the farmers based on the economic results. So that's a step where most bioeconomic models are first bio and then economic. We can have economic bio. And the economic results start influencing what happens on the biophysical side of things. So yeah, there is definitely is important, but the more you ask, the more complex the model becomes, and the more people will complain, but yeah, but it's too difficult. Now I have to answer all these questions about trees, and I don't know anything about trees. I know that it's jati, I just want to say jati, and that's all. So it is our question of packaging. On one hand, how can we be flexible that if people want, they can change everything? At the same time, we create sort of bundles of things that, okay, if a tree is called jati, then you trust me that it has the property of jati. If I call pine, then it has, but if you want, we can go deep. Now, in that sense, we have some basic management rules are there, but in terms of pruning, we first did it with pruning the trees, because if the trees grow fast, you have to prune very often. But then you have a lot of fertility to the soil. If the trees go slowly, it doesn't cost you much labor, but you don't get. And so that the management of what farmers do depends on the situation within the plot. We have a number of those things already done there. But definitely, if you go beyond level 3 to level 4, level 5, we can do more types of things like that. So it's open for any of you to improve on what we have. But there is already quite a lot in the model as it stands. Yeah.
Thank you very much. Yeah, I believe some of you maybe still have question, yeah, but I'm sorry to say that we have run out of the time, but because some of the students also need to go to another course, yeah. Before we close, I would like to have a model of us having a guest lecture together. We will have photograph sessions. So I need all of the students to stand up. Just stay in your place. Just stand up, and then, yeah, Mas Afif will take the picture I would like to ask Pucho to go in front. And also Mbak Putri, where is Mbak Putri? So we make our model, yeah? Yeah. Okay, thank you very much for all of the students. Thank you, Pak Mene. Let's give a huge applause for Pak Mene for the